Now, we're going to hear about this year's BalCCon badge from the creator itself, Flo.
Thank you very much. As this is the second batch I make for BalCCon, or the second batch in my life, I spent even more time preparing the talk, so it's going to be excellent. So you likely will have more questions than answers, that's fine, so you can ask them. Most of you, at least those that signed up early for BalCCon, should have received their badge. Those that didn't, sign up earlier next year. Yeah, with that, let's start. The idea is that, same as with last year's badge, I'm not yet switching the screens, but that's more or less like it. Yours looks a little bit different because that's a development board. Last year's badge, the idea was that you get creative, you can program it on your own. It is a little bit more complex, but you know, it's really here to play and be creative. So we thought we'd do the same thing with this year's badge, which is this one. Yeah, and that one's black, so there's a black badge this year as well. Don't try to steal this one. I will know that's not the original black badge. So I would like to give you a short introduction of what this year's badge is all about, what was the design process, and what did it look like. Maybe you want to take out that URL, because that's the documentation there that should keep you going. I know it's not very good. It's finished like 2 minutes ago, so bear with me. Also, there might be firmware updates during the conference. The most important thing is you currently have a test firmware on your badge, which is pretty boring. So you will get the conference firmware after this talk at the modding station. It's in the main hall, all to the back. You will find it. I will likely be sitting there, and I will have 1 or 2 gentlemen helping me flash the badge. That's also where we have programmers. So if you want to program your badge, or if you think you need a programmer for something else, hint, then come by, use it at the desk. Don't take it with you. We have a limited amount of programmers. If you take them with you, others will have a problem. When we near the end of the conference, we might sell some of the programmers. They're owned by BalCCon. They will go for €10. So if you want one at the end of the conference, talk to the guys. You can also convert an ESP32 into a programmer or Raspberry Pi. If you want to know how to do that, talk to me at the desk. I've never done it before, but in theory I know. And what could go wrong in practice, right? Now, another very important thing. I'm putting out the important things now because when people leave, then at least they know. Your battery should be connected to the badge. It doesn't run without battery, right? So that little cable needs to be plugged. Red goes to the pin marked with a dot. Ground is the pin below. Now, if you plug it in somewhere else, remove that battery connection. It's not going to blow up. It's maybe releasing magic smoke. I haven't tested. That badge needed to be cheap, so there's no reverse polarity protection. It doesn't matter. It doesn't blow up. That I tested. There's no overvoltage protection, undervoltage protection. That's all your responsibility. The badge runs from 3 volts up to 5 volts. So be considerate of what you connect to it. So with that out of the way, let's get started. No slides in this talk because no time. So on the side, you will see the schema of the hardware. Let's start with that. The requirement was, last year's badge was pretty expensive to manufacture and also to buy. We still believe it is a great badge because it allows you to do many things. It supports Bluetooth, Wi-Fi, it has interfaces, nice LEDs. But we wanted to do something that is a little cheaper this year and that we can just give you if you sign up early. And I stumbled upon a nice little chip, which is the CH33V003 from VCH. It's a Chinese manufacturer. It's a RISC-V chip that if you buy it at large quantities goes down to 10 cents. Now that said, this chip has some limitations. It's got 60 kilobyte of flash RAM for your code, so your code can't be bigger than 16 kilobytes. And yes, Nintendo made games smaller than that in the old days, and also C64 peoples and others. So you can do stuff, but you need to optimize your code. So that's one. And the second is also it has I think it's 2 kilobyte of effective RAM. There's no dynamic memory allocation, so don't try to use malloc. It won't work. It's all fixed registers. It's all fixed stuff. You can program it in C without a problem. There are examples to look into. I will walk you a little bit through them. Otherwise, come to our desk, check it out. Now, you see here, that's the heart, that's the processor. We have some pins exposed on this neat little external interface. That's, when you look at your badge, that's these connections here. They all share the same connections. You can plug it in however you want, right? Now, the important thing is, if you have last year's badge, it does plug in. And it is powered from last year's badge. And it does have 4 pins that allow it to communicate with last year's badge, and there's even a demo software I will show you. And now, before this gets annoying, I'll take it off. So that's the purpose of that. That's also how you connect it to the programmer. Check the pins. It's very simple. I will show you at the desk. Doesn't really make sense to show here, but hooking up a programmer. You can just use some cables. We have some at the desk. They're very flimsy, so maybe you have to push them a little bit to make them work. It's Chinese quality all over the board, so they break easily. We got extras. Then what else do we have on the badge? We have the display. So let me go into the details here. That's basically the same as last year. It's an ST7735 LCD display. Nothing fancy to it. The driver is on GitLab. When you read through the article, you will find the driver. Straightforward to use. Then we also do have a buzzer. Where is it? Down here. So that's this tiny little black thing down here. That's what makes all the noise. The buzzer is a piezo buzzer, so basically it's vibrating. And the idea is you switch on and off a GPIO to determine the frequency in which it vibrates. There's a sound library that allows you to make sounds. And actually Meow, who's here, don't know where, did a neat little firmware. Where is he? Over there? That's the man. By the way, without him, that badge wouldn't have been possible. He helped me a lot with the software development. Thank you. So he met a composer where he can compose melodies to annoy your neighbors. And trust me, so I was working on the firmware till 2 o'clock in the morning last night, and on the airplane, people hated me a little bit when I was doing the testing. But you know, you can only do so much. Then there's another thing. You have 6 buttons on your badge. It's basically like 2 controllers, to the left and to the right, 3 buttons each. 3 buttons share one GPIO, one general purpose input and output. So you see here, for example, you have the pad 1 and pad 2, and they connect exactly to 1 pin at the chip. Now, how do we do that? The pins are configured as analog to digital converted. They measure an analog voltage and convert it into a digital representation. And by using different resistors, when you push a button, the resistor value changes. And by that, the pin will know, or the pin can read the voltage value, and the program will know which button or which combination thereof was pressed. Also, there's a library, because calculating these values is a little bit rolling of dice. I'm sure you could do it properly, but that math is way too long since I did it, so I decided to just roll with it, and it works. Good. Otherwise that, there's solder jumpers on the board. Do not resolder them. They were mainly for configuration and testing purpose. And there's an on-off switch. Now that is important. If your badge doesn't run, if you can't flash it, turn it on. You're laughing. I forgot that many times and I was looking for the problems. Also, that on switch breaks very easily because it's tiny. Be gentle. If you break it, I have a couple of spares. We could potentially solder them in, or just don't bother and leave it switched on. Remove the battery if you want to shut it down. That's your options. Good. With that out of the way, we looked at the hardware. We looked a little bit at the processor, display, the buttons, the external interface. So let's talk firmware, because that's ultimately what is interesting. There are So you received your badge here. You can, by the way, you can build your own. I will release the files without the BalCCon logo, so no one will have the logo as you do, but I will release the design files. You have the test firmware on there. The test firmware, as I said, is good for testing the badge, but not for much else. That's this hardware test. If you're interested in how it works, it's more or less self-explanatory, except the second stage. You have push left up, right bottom button to confirm the test, or the two top buttons to deny the test. Again, doesn't matter, it just shows you the right number. To that point, you will already know it works. And yes, someone approached me about, if the display doesn't work, you can't read it. Yeah, but what to put there, right? I mean, okay. Then we have the Melody Maker that I mentioned. Let me briefly show you this. So we have the Git repo of this Melody Maker, and I think that's the important part here. I'm not going through the code, but you see the code is released. If you have any questions, ask over there. But let me quickly switch cameras. Yeah, we good. So basically, if you have Visual Studio set up properly, you will be able to flash your badge from the IDE. You don't need to do that. There's an easier way. I will show you afterwards. But when you have it properly connected, the badge, through this nice little programmer, and it flashed correctly, this is your melody editor. I think the image is okay. Is it visible? Yeah. So in the beginning state, BPM in the upper right corner is selected. You can use the bottom two buttons to move forward in the notes or backwards with the other one. I can't reach it. Now, with the top two right buttons, you can change the duration of a note. There's a teeny tiny little indicator underneath, and you can change the height of the note on the left, pushing down and up. And if you stay on there, it moves faster. The dashes that you see, those are silences. So you can enter silences because, music has silences, and also adapt there. If you go back to the BPM menu, you basically walk through either that direction or the other one if you want to be quicker. If you go to the end, you go one further, you can add a note. If you don't add a note, go one further, it goes back to the BPM, plays your music. BPM, you can adjust the speed with these buttons and make them faster or slower. Good, so that's the Melody Maker. That's the annoy your neighbors thing and get creative. So we can go back to the screen, yes, thank you. As I said, you will find on that page either the GitLab page where this is, so you can check the code, or the binary. I will tell you how to flash the binary in a second. Then we also have a little Pong game. So for the Pong game, I will need that back in a second, but no need to rush. Let me show you quickly the Pong game. There is one important in the test in the GitLab. So if you go to the main header file, That's the important part. So because the Pong game, let me quickly flash it, and then I can show you on the camera soon. Thank you very much.
It's so laggy.
Okay. So now the Pong game, if you connect it to your old batch and you come and you let me flash a new firmware to your old batch, which is not very polished, but it's there, or you do it yourself because you already know, then under games on the old batch, so we enter games, there's a Pong game. Who would have thought? So with Pong selected on this batch, we press the bottom right button to make the player ready. Up, yeah, so. And then on the batch, we start the Pong game. That's wrong, sorry. Let me restart that. It's flimsy. So, maybe I put it here. Mark ourselves ready down here. Then go to the games, start the Pong game, go down here, and you can play Pong against your other batch. So that's just an example of what you can do, and then try not to lose. If you don't have an old batch, but you still want to play Pong, there's actually two other options. You have Pong selected, you mark with the left bottom button player 1 ready, with the right lower button player 2. Now this is ready. Now you can either play against yourself, which is more fun than you would think, or you can actually play against someone else. So then it gets cozy and you get to know each other. But that's good for all these people that don't like to get to know other people. Play a session of Pong and you will make friends. Good. So that demonstrates how this works. The protocol is in the header file. If you want to modify it, if you want to play with it, if you want to work on your own, it shows you how to use I2C. In that case, I use I2C as a protocol to communicate between the batches. So that's that. Good. Now, if you don't want to set up the development environment, and there's a link on an article I wrote for the dev board for the CH33. You can follow that article, or you can read the GitLab of CH33 V003 Fun, which is way better library. It's all there, or come ask me, no worries. But if you don't want to set up the environment, if you basically just want to flash different firmware, if you have Rust installed on your computer, there's a pretty nice tool called WLink. And let me briefly search it. You can install it. I think also for Linux there's some precompiled binaries and repos, same for Mac. And then you can just download the firmware and flash it with WLink flash using a programmer, of course. So if you want to flash different firmwares, come grab a programmer. You can easily do it on your own computer without having to set up the full development environment. Yeah, there are additional documents like the datasheet, the reference manual, the debug manual, the processor manual, because it's a RISC-V processor, so have fun with it. There's the schema, there's the documentation of the display and the piezo buzzer if you want to get crazy with it. Why does it have 6 of these connections? If you want to get creative, you can chain batches together. You could communicate using I2C. You can do other things as well. After the talk, if you want to take up the batch challenge, come visit us at the modding table. We will flash for you the conference firmware. That's not publicly available. And then if you solve the challenges, you might win a black badge. First one takes the black badge. Everyone else takes the fame of solving the challenges. And with that, happy conference. And if you have questions, now's the time to ask.
Does anybody have any questions?
One back there.
How long was the development time of the badge?
Oh, it depends. The hardware was ready, I think, last December or November, theoretically. And then I needed to put the graphics on, and that's kind of annoying, and I didn't do it for a long time. The firmware development, it's hard to say. I did it on and off. I would say the batch itself, I did a couple of other projects, like I'm working on a workshop with that chip and with a similar configuration that should introduce people to digital design and soldering. I don't know, maybe a month in total. The firmware, as I said, finished yesterday, 2 o'clock in the morning, but I was like, whole of August I was not in a programming mood, and that was a bit the problem. But yeah, thanks for asking. It's a little work. It wasn't as much work as the other one, because that was the second one I did. You get a little bit more routine. Yeah. Oh, by the way, if you broke the display of your old batch, come see me. I got new displays because dogs and so. Good. Yeah, one more question over there.
You said if you plug it into the old batch, then it will be powered by the old batch. What happens if you plug multiple old batches to this new batch?
If you plug
the new batch, as they have 6 options to plug something in or be plugged in to 2 old batches.
Try it and tell me. So that's likely going to end in disaster because your old batch is pretty powerful in supply voltage. So you shouldn't do that. But you can connect multiple new batches and chain them and supply them from the old batch. But yeah, I should have considered that someone comes up with this idea. Good job. Thank you.
A bit unrelated to the badge, but I was wondering, who made the large display out in the hallway?
Who made the mate wall? Tomer initially. So he's not here because he has a life now. So we're not good enough for him. I just want to put that on the record. That was the most important event in his life, and now something changed. Can't explain. No, joking aside, that was Tomer. I think Brian knows a little bit about the mate wall. Where is he? Hiding over there? Brian, he's also giving a talk. Listen to his talk. He's a smart guy. So ask him about the wall. And I think many people were involved in the project also from here, from all over the place. Many people contributed and developed different parts of it. And I just failed to name them. That's just the 2 guys I worked with. That's why I know them. So, yeah. One over here.
Do we need a laptop for programming the batch with Programmator?
Yes, so you need a laptop to program the batch. If you don't have a laptop but you want to change firmwares, bring it to me, I will flash it for you. Mm-hmm. But to program you need a laptop. Any operating system should work. On Linux you need to set some UDEF rules for the USB programmer. I just copied that because I don't use Linux. I did that when I was young and masochistic. Yeah. Yeah, no, it's not a popular thing to say at these conferences, but you start to enjoy working software. Shots fired. Good? Okay. Thank you very much. Have fun with the badge. Have a good conference. Bye.